Welcome. Thank you so much for coming tonight. It is a pleasure and an honor to have you here. You are at Codis Craft, if you are unaware. Um, this is Etsy Engineering's way of contributing to the tech community, both by sharing what we do and by trying to amplify human-centric ideas in tech. Um, we've actually been hosting this speaker series for 8 years now, which is kind of mind-blowing. But in the grand tradition of Codiscraft, you can also check out our blog, where we have a lot of interesting posts and articles about how we build Etsy. Recently, we posted about refactoring images. There's all kinds of topics there. But one of the things, as I mentioned, we really try and do with this is bring out some of the cultural and social components of tech. An underlying truth that we want to recognize is that technical systems are intrinsically linked to social systems. And within that, we are conscious that to improve our technology, we have to be conscious of and improve our culture of technology. Etsy has been really wonderful and has done a lot to build a diverse engineering team over the years. And we're lucky to have a strong community of women and non-binary people who have built out an employee resource group to help build connections and empower women and non-binary people in technology. We have technical discussions, we share knowledge, we talk about career growth and various challenges that come up in the everyday office life. But mostly it's a space to meet like-minded peers and talk about everything that we have in common. So tonight, we will be featuring 6 of these lovely people. They will share their technological expertise, and we'll have questions, time for questions at the end. So hold on to them, please remember them, write them down. We will get to them. With that, I would like to introduce Stefanie Schirmer, who is going to show us how to build a shell in 5 minutes.
All right, let's do this. Hi, I'm Steffi, and I'm your friendly hacker from Berlin and also Brooklyn. Let's build a shell in 5 minutes. So what is a shell? The shell is an interface wrapped around the kernel of each computer's operating system, where we can run commands. So it's kind of like the operating system's interface to the rest of the world. It's very important. Every terminal we open has a shell. And we're building a tiny shell. It's very simplified. And we're writing in C, but don't worry about it, we do it together. Our shell should have a prompt where we can input things. It should parse our user input. And it should run commands and show their output. So we need a main function and a loop. So this loop is running forever while 1 and printing the prompt. And then with fget_s, we get max line characters from the standard input, which in this case is my keyboard. We check for errors and for the end of file. And then we remove the trailing new line from the input and we can evaluate it. So remove trailing new line and evaluate it. Okay, that was easy. So now we have a shell that's very lazy. It doesn't run anything. Okay. What do we do now? So to run something, we have to parse the command line. We have to read it and to have to make sense of it, make sense of its structure. What is the structure of a command? Let's build it. Let's build a data structure in C. It contains the number of arguments, and then the argument list, including the command itself. And then the next thing we need is a function to parse the line to fill the structure. And it's also a while loop. It's stepping through the line character by character. And it's splitting it up into words called tokens. And the white spaces you can see up there are delimiters between those tokens. And we break when we reach the end of line. We read up to the next delimiter, terminating this token string with a null character, which is how strings end in C. We don't have to worry about it. And after we have read all these arguments, we end the argument list with a null pointer. So we know it's the end. And then last thing, we check if there's an ampersand at the end, that's like this line down there, to see if the job should run in the background in our shell. And that's all. And now to execute a command at the level of the operating system, what do we do for this? We make a system call. Let's look at the mother of all system calls. It's called execvp. I looked at the man page for execvp. It says execute a file. So what happens when a file with code or a program is executed? Let's try it. Let's run ls, for example, listing what's in the directory. So what happens when I run this? Start is being printed, and then I do my execvp with my ls, and then it does not print and done. Why is that? It replaces the current process image with a new process image, morphing the current program into another one. And that is weird. If execvp returns an error has occurred, normally it would just run the other program it morphed into. Okay, great, we can run the command. Or maybe not so great, because in this way our shell would become useless after one line of input, right? So how can we fix this? Fork to the rescue. Fork takes a process and it makes another identical one. So let's look at this example. So if we would run this, what would it print out if we run this? It would print before fork, after fork, and in between the forking happens. So before the fork, we have one program running, and afterwards we have two. Also, the parent forking returns the process ID of the child. That's also important to know. And in this example, the parent runs first. So can we also make the child run first? To do this, we can use wait. Wait gets a PID and waits for that process to finish. And we can let the parent wait for its child to make sure the child runs first if we need it. If we combine fork and execvp, we can use the child process to run the command, keeping our shell alive as the parent. So what does this look like in practice? First of all, what does a real eval function look like? So let's say parsing we did, yeah, we already looked at that, and we ignore the empty commands, right? And then a command can run in the foreground or background, and that's why we pass bg here. Yeah, it's not so difficult, actually. And then let's look at the run command function. We need to record the child PID in order to decide what different things to do for the child and for the parent, right? So that's what I'm doing here. And then let's see what we do in each step. The child can run the command. This is where we call execvp with our prepared struct, which we prepared in the parsing, right? And here we just have to check the exit status to see if the command failed, and we're done. Usually it shouldn't fail, if we're lucky. And for the parent, we have to distinguish whether to run our command in the foreground or background. So that's what we do here with the bg. And if it's in the background, it's very easy. We print the child PID, and then the process is going to do its thing in the child. But if we want to run it in the foreground, we need to wait for the child to return, right? And that's it. We're done. All the shell fits on one slide. Okay, let's try this out. Okay, ls, you can see my example. And then I'm running it. That's my shell, my prompt. And then I'm doing pwd, walking around, pwd. And I'm still in the same directory. That's weird. It didn't work. So what happened here? Our shell actually has no sense of directory because we didn't build it. And there's more stuff missing. So there are no built-in commands, for example, which usually a shell has. There's no job control. We would have to implement linked lists in C. It's complicated, too long. And then pipes, redirections, and file handle, we have no concept of that either. So this all would take more than 5 minutes. But I encourage you to explore, starting from this basic shell and make it more awesome. Thank you.
Um, yeah, this will come up later. I didn't just refer to you as an object. I'm sorry. In any case, something that gets overlooked sometimes is that the wide world of tech, is a really big world. It is not just coding. And the world of tech would not exist without people in community, people who do QA, and importantly, designers. Jessica Harllee is going to talk about tools that help designers and engineers collaborate.
Hey, I'm Jessica Harllee, and I'm a staff product designer here at Etsy. So I work on the tools that Etsy sellers use to manage their shops. I'm also an Etsy seller. I have an Etsy shop, I sell embroidery and weavings, and this is a photo of me embroidering a poop emoji. At Etsy, designers sit next to engineers, we push to production, and we write code that gets used by our buyers and our sellers every day. Our designers and engineers are extremely close collaborators. This is largely because we've made parts of the development process really accessible to designers. So in 5 minutes, I wanted to share 3 tools that we built at Etsy that allow designers to be really involved in the development process. Writing CSS is hard. Changing CSS can also be completely unpredictable. Designers and engineers were spending a ton of time writing and testing CSS. Also, writing CSS from scratch can be really intimidating for designers who hadn't written code professionally before. So a group of designers with a ton of support from our engineering team decided to change how we write CSS. We wrote our web toolkit, which is a set of centralized CSS and JavaScript components. Buttons, forms, a grid, overlays, it's all covered. Designers don't have to be CSS experts to build a sophisticated interface. Because all of the CSS is centralized, it's all been written out and vetted already. You can build an entire page on Etsy that's completely responsive without writing any CSS. Toolkits like this make building pages really approachable. It also means that designers and engineers can speak the same language when they're talking about changes to the UI. A really common example of this is that an engineer will be building something and will need design input. Having all of these styles centralized means designers can reference them when they're communicating with engineering. It's made everyone's lives so much easier. Designers rely really heavily on prototypes to make design decisions. We want to understand how an interface is going to feel when you use it. Static mockups aren't always sufficient, and they're not always going to be helpful for engineering either. A prototype is worth 1,000 words, but prototyping can be really time-consuming. Designers were already using the Web Toolkit to build pages on Etsy quickly, so what if we used the Web Toolkit as a prototyping tool? We pitched the idea to engineering, and they helped us make sandboxes. Sandboxes are basically just a folder with a bunch of template files, and they're hidden from the public. All you do is you add a new file to the folder, you open it up in your browser, and it comes fully loaded with Web Toolkit CSS and JavaScript. As a designer, I don't have to understand routing, I don't have to know anything about a controller, all I know is it just works. Building a quick prototype in a sandbox takes minutes. It's really good practice for using the Web Toolkit, but there are also benefits to our workflow. For me, this has become my go-to way to hand off files for engineering. I can really quickly build a piece of UI in the sandbox, maybe show a few states, and then engineering can take that, port it into Mustache or React or whatever you're using, and then wire it up. Sandboxes work really great for building new stuff, but what about existing things? It can be really scary to modify something that's already out there without fully understanding the impact your change is going to have. So an engineer who had been working really closely with designers developed unit cards with this in mind. Unit cards are a tool that we use to show and test different React components. There are a number of benefits to engineers, but a huge benefit to designers is that we can see all of the states and edge cases for a given component. Instead of having to manually click around and try to show all the different states ourselves, there's one nice page that shows it all, and it's fully interactive. This is so cool for designers. This completely blew my mind the first time that I saw it. If I want to change something that's in a React component, all I have to do is modify the code, add and remove a class, and then I can pull up the unicard and see what the impact is. This makes it really easy for me to make changes and to feel really confident about how it's going to affect the UI. So much of what I showed you wouldn't have been possible without the help of our awesome engineers at Etsy. Thank you. So while I have a captive audience of mostly engineers, I wanted to encourage you to talk to the designers that you work with, or maybe even sit in on a design meeting. What are the barriers that designers and non-engineers are facing to feeling comfortable pushing code? What's hard or maybe even scary for them? Maybe there's something that you can do to make their lives amazing and to make collaboration even better. Thank you.
And now I would like to introduce Davina, who will be previewing a talk she's giving at O'Reilly later this year on Amazon Web Services.
Hi, welcome to Etsy, everyone. My name is Davina Dhawan, and I'm on the infrastructure security team here at Etsy. You're about to learn more about what I did to secure AWS infrastructure here at Etsy. I will have the longer form version of this talk available on my Twitter at the Olzo. Don't ask me what that is. Made it up a really long time ago. And there's a lot of information here today, but there's like even more information available in the longer form talk. Etsy infrastructure is mostly traditional bare metal with a minimal footprint in cloud infrastructure. Most tools are designed for our own hardware, and teams are generally deciding on what their needs are and order hardware based on those specifications. Every company has clutter. You go through acquisitions, you need to run external scans, and especially if you want to hire like a contractor or something like that for a month, you don't want to give them access to your entire infrastructure, right? So you throw it up in the cloud. All of that and above can account for some clutter. And at Etsy, that meant that we knew of half of the root AWS accounts that we had. And even on one of those accounts, we had maxed out on the number of S3 buckets. And a large chunk of the Etsy engineering organization even had administrative accounts on AWS. To give you a better idea about how things should really be, most organizations only have a single root account with a few number of administrators, and then the rest of engineering doesn't really touch AWS. They just like do everything automatically. And in order to figure out where to begin when I was handed this project, I started running scans on our AWS accounts that I knew of on a tool called Evident.io. Evident.io is just a tool that like just verifies that you have correct configurations, and a free version of Evident.io basically is a tool called Scout 2. It requires a little bit more finesse. It's by a company called NCC Group, and basically it just gives you reports for all of your AWS accounts. So if you have a bunch of them, it'll do it really, really well, and then you can just like create a diff on that and then alert. And we'll talk about alerting momentarily. So Evident.io just takes a little bit less time to initially configure, and then Scout 2 takes a little bit more time, but that's what happens when you pay for stuff. Note, I have pet rabbits. That'll become more clear because I'm obsessed with them. So I started getting a general idea about how things looked from a misconfiguration perspective when I was looking at Scout 2 and Evident.io. And I started creating JIRA tickets, mostly to list things out for myself, because things got really confusing, and I had no idea what an ACL was at the time. And so I'll be talking about two of the main issues that Etsy was experiencing. The first one being monitoring. Monitoring and general visibility are one of the most important components of security. If a resource is being touched, you want to know what has been changed, and if possible, by whom. I figured that logging would be something that I needed in this new world order, so I started to read up more about CloudTrail. Whereas Evident.io and Scout 2 are essentially just looking at misconfiguration, you can also easily turn on CloudTrail, which allows you to log every single API call. Here, I've created a CloudTrail called Any Logs Would Be Nice, and that would give me all of the events which occur with regards to the S3 bucket called Golly. I've also created a new location for all of these logs called logs.golly. The infrastructure security team and the systems engineering team work really heavily together. I talked to operations and asked them if there was anything that I could be doing with the logs that were sitting in S3. They told me they got it, and they totally did. Pretty soon, I was able to see all of my logs in Kibana. Even though they weren't parsed properly, I dealt with that later and then put them in 411, which is what the infrastructure security team here uses for alerting. So talking more about alerting, Once you have logs and alerts from a scanner, you need an easy way to be able to digest them. Depending on what you have going on in your infrastructure, you can send daily roundup emails or high-risk emails only. It's entirely dependent on your capacity to manage these alerts and remediate them. You can also use some examples from Slack and Dropbox on how they leverage chat clients to remediate alerts. My recommendation, however, is just to have all of these alerts sitting in one place. You need to be able to gauge what needs to be done quickly, and nobody has the time to log into like 5 different places to look at alerts. At Etsy, we use 411. 411 is an in-house built tool that queries Elasticsearch and allows you to get email notifications even based on like alert severity. This one's just so cute. Oh my God. Right? Yeah. I know. I'm obsessed. Okay. We used to get a bunch of bug bounties by people reporting world listable, readable buckets on Etsy. Even though it was really just static image content, it was quite frustrating to figure out what the appropriate bucket permissionings should be. We also didn't quite understand how people were able to find our buckets like world listable so quickly, and it's because they were regularly scanning us, obviously. Like within a week of being misconfigured, we would get a bug bounty email. If you are curious as to what buckets are publicly available, listable, writable, what have you, and you don't have any other scanners like Scout 2 running, you can use a tool called S3 Scan. It's really lovely. Bucket policies are really interesting because it blows my mind that with just a click of a button, you allow everyone in the world to modify your buckets. It should be a little bit more difficult than that, especially if these buckets are internet facing. And like that, and another point to point out is that any authorized AWS user here under Manage Public Permissions is a public AWS user with an API key. It's not just like someone in your organization. So just pretend that that's basically everyone. So I have a bucket that I mentioned earlier called Golly, and it has all of the permissions turned on. You can see here on object access and permissions access, it's got read and write. My recommendation, turn it all off. You want to do everything manually so that you have a lot more granular access. And under Bucket Policy Creator, you can create these bucket policies. And it's really, really nice. You can get as granular as you want. You can make it so that only the Deborah application can even access this bucket. Awesome, thank you all so much. Who learned something today? Yes, awesome, great, thank you.
You may or may not have noticed Katrina Walser over here knitting in the corner. It's something she's very good at. She is also a very talented engineer. And I would like to introduce her to the stage, and she will talk about how knitters are human compilers.
Hi everyone, my name is Katrina Walser and I'm an engineering manager here at Etsy, and today I'm going to talk to you about knitting and coding. So I've been knitting for a long time. Someone taught me back in elementary school. This is a picture of me making a baby blanket sitting on top of another blanket that I also made. I also needed to put in my own picture of my personal big pile of yarn because Davina had one in her slides. This all lives in my house and it's not all of the yarn that I own, but that's embarrassing, so let's just move on. Around the time that someone taught me how to knit, someone else taught me how to code. And so I've been doing both things for a very long time. If you want a sort of indication of how long, the first thing I learnt to write was QBasic, if any of you remember that. And so the more that I do it and the longer that I do both of them together, the more that I realize that there's a lot of similarities between the two. And the conclusion that I've come to is that knitters are human compilers. Well, almost. I lied a little bit. They're not actually compilers, they're more like interpreters, which is a distinction we'll come to later. But I just couldn't call my talk knitters are human interpreters because it sounds like I was saying that knitters interpreted humans, which is weird. But let's just stick with interpreter from here on out. So an interpreter is a software program that takes a set of well-defined instructions, which we call code, reads them and executes them, and turns them into other usable software like a website or a social media app, or in this particular case, the Shop Advisor, which is a tool we just launched to Etsy sellers. A knitter, on the other hand, is a human who takes a well-defined set of instructions that we call a knitting pattern. They read them, they execute them, and they turn them into a garment that someone can use, like a blanket or a sweater, or in this case, a pair of baby booties. So for those of you who have never seen a knitting pattern before, it's a lot like a recipe, except unlike a recipe that shows you how to make food and is written in basically natural language, knitting patterns are written in a very specific format that you need to learn to write if you want to write them and read if you want to read them. They look a lot like code, and it's because they have a set grammar, and it's a very small one at that. Because of this, we can draw a lot of parallels between what code looks like and the concepts that you have in knitting, and so I'll take you through a couple of examples. This instruction here, highlighted in orange, is how you indicate repetition. You read it as do K 12 times. In programming, we'd call this a loop, and in Python, it looks like this. Ooh, yep, there you go. Looks like that. If you expand that instruction out a bit to include the piece in the brackets, that's how you indicate size. So the way you read this bit highlighted in orange is if you're making the small size, repeat K 12 times, and if you're making the big size, repeat K 15 times. If you put that together with the loop from the last slide, it's actually a nested if statement. Looks a little bit like this in Python. The last concept I wanted to show you is around reusability. A lot of knitting patterns at the top of the section before the main body of the instructions will have a section called notes. And within the notes section, they have these little chunks of, sorry, I was about to say code. They have these little chunks of instructions that aren't really useful for themselves. So if we take this cable pattern here, it's only got 4 rounds in it. And for context, like an adult beanie usually has about 50 to 100 rounds in it. So it's very small and it's not super useful in and of itself, but what it is useful for is later on in the body of the pattern, there will be references back to it that say, do the cable pattern or repeat the cable pattern. Every time you see that, you go back to the note section, you do the 4 lines that are indicated in there, and then you go back to where you were at and keep going from there. I can see a lot of you nodding, so I think you've drawn the conclusion I'm about to get to. It's a function. I haven't actually got the Python equivalent of this because this whole thing would be a big mess of nested function calls and if statements, but I'll leave it up to your imagination. So the big question that I'm hoping some of you have is, I can code, can I knit now? And unfortunately, the answer is not quite. So the distinction I was making earlier between compilers and interpreters is that interpreters actually execute the codes that they read, and so you need to learn how to knit. The reason that I didn't have a fancy code equivalent for K is that it is the standard token of the knitting pattern language, and it stands for knit, funnily enough. If I can get this to work. In practice, this is what K12 actually looks like. And this is a piece that takes a lot of time and practice to actually sort of get good and fast at. But if any of you would like to learn, come find me afterwards because I love teaching people about this stuff and I'll point you in the right direction. The conclusion I have drawn from this, though, is that I have a hunch that knitters can learn how to code really easily. I get the feeling that people who know how to read patterns, and especially people who know how to write them, will be able to pick up coding really fast. Because I think what will happen is that if you're trying to explain to them a concept like an if statement or a while loop, if they don't understand, you can just point back to a pattern and be like, hey, this is a thing you get, and it's the same thing. So you can wrap your head around it that way. I haven't actually tested this yet. So if any of you know how to knit and you don't know how to code, or you know anybody who fits that bill, come find me afterwards and I'll give you my email address because I'd really like to try it out. Thanks, everybody.
Thanks, Katrina. Now I would like to bring to the stage Ayla Myers, who will be talking to us about something that at least sounds very cool, generating images with Wavefunction collapse.
Oh, hey. Howdy, everybody. So, like Lisa said, my name is Ayla, and today I'm going to be talking about Wavefunction collapse. If you haven't heard about it before, I'd highly recommend checking out the GitHub repo. It has a lot of good information, good images that can get you started. It's really interesting stuff. But to kind of get into it, Wavefunction collapse is an algorithm, and what it does is you feed it an image, like you can imagine these different images I've gotten here. So those could be 3 different inputs into the algorithm, and then what it does is it generates an output. So these are the types of outputs it would generate for each of those inputs. So essentially what it does as an algorithm is you give it a small image and it can generate images that look similar to it. So pretty cool. We're going to go through how it works and why it's cool and some limitations of it. This talk is only 5 minutes long, so let's talk about some quantum mechanics. So this algorithm doesn't actually use quantum mechanical equations, but it does borrow heavily from the same metaphors, so it's useful to go into it. So in quantum mechanics, if we were trying to figure out exactly where a high-speed particle is, to start, before we actually figure out where it is, we represent it as a waveform. And the reason we do that is because we don't know where it is exactly, but we have an idea of where it is, and so it's sort of like the probability of where it most likely is. If we want to figure out where it is exactly, what we do is we observe the waveform, and that causes it to collapse to a specific point in space. So the thing to take away here is, before we observe a particle, we represent it as a superposition of all possible places it could be, which is what a waveform is. And then we observe it, and it collapses to a particular point. This is important. No test afterwards, though. So what we're going to do is we're going to run through how the algorithm works, and we can go from there. So the first step is you just need an input image. So I drew something. Yay. And essentially what this image actually is it's just a grid of pixels. So a pixel is just a small colored square. You can see I've drawn the grid here of where those are. And the first step of our algorithm is we're going to take our input image and we're going to cut it up into 3 by 3 regions. So we're going to collect every pattern in the input image of 3 by 3 collections of pixels. So you can see one of the patterns that exist somewhere in the input image is they're all white, one has all red on the left, et cetera, et cetera. We're going to collect every single one of those that we can, and we'll set them aside. And then we're going to initialize our output image. And we talked about the waveform before, and now it's a superposition of all possible places that a particle could be. In this case, we initialize our output image such that every 3 by 3 region in the output image is a superposition of all possible patterns that it could be, which is why it's purple, because it's blue and red. You guys know quantum mechanics. So this is not so useful because what we have here is an image that's a superposition of all possible images, which isn't what we want. We want one image in particular, so we need to collapse this to a single image. So what we do is, following the same similar quantum mechanics stuff, we'll pick a 3 by 3 region in the output, and we'll observe it. And in this case, for this 3 by 3 region, anything is possible, so it can collapse to any of the possible values. Maybe it collapses to that one. In coding terms, if you were going to write this algorithm, we would just look at all the possibilities for this and choose one randomly. And then we just plug it in there, easy peasy. But this has implications. So when we collapse that 3 by 3 region to a particular pattern, now this 3 by 3 region only has so many things that are possible for it because we don't want there to be any conflicts. So in the next step, we need to propagate the implications of that choice outwards. So we observed a region, and now we need to update every other 3 by 3 region in the output image such that no illegal moves can be made. And then from there, it's a pretty easy process. We just repeat that. Each time we choose the 3 by 3 region with the lowest entropy, that is the 3 by 3 region in the output that feels most certain that it's going to collapse to a single particular pattern. We observe each 3 by 3 region, it collapses to a single pattern. We propagate the effects of that outwards, and if we just repeat that over and over, we'll end up with an image that looks roughly similar to the input image we gave it. And if we were to see what it looks like when a computer does this, it looks something like that. And you can kind of see it like deciding and flipping between spaces where it feels like it has certainty about what the color is going to be. Why is this cool? Well, unlike neural networks or Markov chains, we don't need to spend 10 hours feeding a library into this algorithm. You just have one tiny input image, and then it can generate an output image that it feels is similar to that. So that's really powerful, and if you're like a pixel artist like me, this is really useful for like generating a field of grass or lava or whatever. So cool stuff. Limitations. So this algorithm is pretty bad at replicating high order patterns. Like in this case, the algorithm believes that it's giving me back a pattern that has similar shapes, a similar texture, et cetera, et cetera. But our human eyes just look at that and we're like, those aren't letters. But it doesn't know what letters are, so you can't really blame it. So this is the wrong algorithm to use if you want to reproduce some like complex shapes. But if you're doing something like what was seen before, where it's kind of like noodles, I guess you could say, then this is really good for it. Anyways, thank you all. You can follow me on Bridges. Thanks so much.
Thanks, Ayla. And last, we're going to take you on a adventure in the meta. And Alex is going to show us the technology that makes events like these possible.
Hi, my name is Alex Daud, and I'm an engineer on the audiovisual team at Etsy. Tonight, I'm going to talk about how my team supports CodasCraft. This is my team. We're the 5 people who support the 1,000 Etsy employees' audiovisual needs. We also support external events like this. If you've been to a CodasCraft before, you might have seen one of us. Or not, because we sit in that back room pretty inconspicuously. Tonight, Sarah's running this event. Everyone, wave to Sarah. Hey Sarah, what's up? Simply put, CodasCraft couldn't happen without us. I'm going to speak about the AV magic that happens in this room that is output to the world. But first, a quick history of streaming at Etsy. We use a video conferencing enterprise system called Video with a Y, which is one of the systems my team maintains. It's on all of our computers and in all of our conference rooms. Video can record and webcast meetings and got us pretty far with those needs. However, the audio quality left a lot to be desired, especially for broadcasting our company-wide meetings, which usually begin with a musical act. Plus, without using a CDN, Video's webcasts would pull from Etsy's network about 2 megabits per person. Almost 400 of our staff work somewhere other than HQ, so we rely on our broadcasts to relay important information to almost half the company. In early 2016, Marissa Zuppi, who is now the manager of AV at Etsy, pioneered our bespoke professional streaming platform. She and Josh Henning, who's an engineering manager as well, worked with some designers and engineers within Etsy to put together Etsy Live. And earlier this year, I upgraded it from Flash to HTML5, which works better across all devices, uses less CPU, and is more secure. This is what it looks like in action. In mid-2016, Etsy moved into this fancy building, which opened the world of AV possibilities even further. Which brings us to here and now. Look around you. Behold the audiovisual wonders of Etsytorium. So what's going on here? There's a lot more than just 2 projectors and a podium. In that back room, we have 4 video conferencing codecs that give us video in Etsytorium and some of the adjacent rooms. 4 PTZ cameras and a controller. These things are awesome. I love them, and you'll see why in like 6 slides. 2 12-channel audio consoles where we control how things sound in the room and over the live stream, including adding sound effects. Like if you ever wanted to sound like a robot, we could probably do that. 2 video production switchers where we set up the camera shots that go out to video and to the live stream. 1 video encoding server. 5 HD recording devices, 2 48-channel audio processing servers that have analog inputs for mics and VoIP, built-in digital signal processing for things like speech enhancement, and network connectivity for configuration and control on AVB. Plus a 32-channel modular matrix switcher for video and audio to route it all. And to think that most people who walk through that door are looking for the bathroom. For those of you who are viewing online, hi mom, it's pretty amazing technology that's bringing my face and voice to you with a delay of only 30 seconds. As Sarah manipulates the cameras and mics using the consoles in the control room, the production switcher and the audio mixer output their separate signals, which enter the distribution matrix. Those feeds can go to video with a Y, to a recording device, to our encoding server, but most of the time to all the above simultaneously. The encoding server outputs an adaptive bitrate stream to one of our content delivery networks, or CDNs, which means that even when you're on crappy hotel Wi-Fi, you can still see the goings-on in Etsytorium. Our CDN also provides the media player you saw that I've designed with CSS. That player is then built into any web page, including the one you may be watching on now, www.codiscraft.com/speakers. We can use those same streams to go live on Facebook, YouTube, etc. Also, fun fact, I realized last Thursday that the Codiscraft player was still running Flash, so I reconfigured it for HTML5 and finished that like 6 hours ago. So I hope everyone watching online is enjoying their viewing experience. So I consider myself pretty lucky to get to work with folks across the company to produce these events because working in AV is both creative and technical. Plus, I get to make really great GIFs. Yep. Cool. So what's next? There's always a lot of things that can be done to improve webcasting. We're continuously working with security to keep bad people out, and we'd like to implement closed captioning. An audio-only stream would be handy and not too hard with HTML5 for the truly crappy Wi-Fi times or for folks who want to watch while in their car. And that's all I have. You can find me in the wild on social media under my name or find me after. Thank you.
It is switched on. Oh. Hey. Thank you all. B, I would like to now open up the room for questions. I hope you wrote them down, because I told you to. Please, yes, this mic will be on.
Is it on? Yes. I apologize. I'm going to do the not so much a question as a comment. I'm a member at New York City Resistor. We strongly believe that knitting and coding are almost the same thing. And every second Monday night is open to the public, and it is knit night where a bunch of engineers get together and knit. So we would love to have you by.
This is your opportunity. I know they're in the back of your brain. Just waiting there. Well, you'll be glad to know that Steffi, Davina, Ayla, Jessica, Alex, and Katrina will all be joining us for some snacks and some drinks, but not before we hear another question.
Sorry, I came from the side, so I was like, Ayla, I believe? Hi, so I just like went through a crash course with quantum mechanics, and I think this is really cool. So I was wondering, were there any other principles of quantum mechanics that you thought that could be applied to something like this? You said you were a pixel engineer, or so I just wanted to kind of like see like what else, like possibly, I don't know, along with the wave function, maybe something like the different interpretations of quantum mechanics, like the Copenhagen interpretation or the many worlds interpretation or something like that. So I'm rambling, but your ideas. I'm sorry, I really love quantum mechanics. Sorry.
No, that's really great. I think my first question for you is, did I get any of it right?
No, you explained it very succinctly. So like the wave function is pretty much a scale of probability. So
Yeah.
I was just wondering if you had any other ideas on how like quantum mechanics could be applied to something like that.
No, but that's really super fascinating. I think the interesting thing about the algorithm that I showed is that it's relatively recent that someone came up with it. Someone just tried it and they were like, oh, this works. So I think right now people are really starting to explore it. So like my community that I usually follow is on Twitter, and they do a lot of like people are iterating on it right now and just seeing what else they can do. Me personally, I'm not a quantum mechanical expert, as you could see. So like I can't.
You explained it fine.
But it's hard for me to imagine what all the possibilities are. I think, yeah, I'd say definitely like bring that up and like find online communities that are talking about this, because especially someone who knows quantum mechanics, I think there are a lot of other areas to explore here. So I don't know, but that's really fascinating.
Okay, thank you.
Hey, what's up? I'm a plant. I'm actually an engineer at sea. But I had a genuine question, and it was for designing tools to help designers and engineers collaborate better together. Um, what is that? What does that like pie in the sky tool look like? Like what ends up being the? Because like this is definitely something like I'm not gonna work on this tomorrow, but but I'm always curious because like you said, unit cards became this like really useful thing for engineers to use.
Yeah.
And as someone who's been working in like front end engineering for a while, I don't have any more asks of it really. But like every once in a while I'll complain like, why don't unit cards do this? And then like I can go and fix that, right? But like what is your current, oh man, I wish I could do this, and like how close are we, or like how far away from it? And like if you had the like infinite time, infinite money situation, like
Wow. I guess first of all, like designers love tools, and like I feel like that's kind of like, I don't know, like designers, I guess this is like a generalization probably, but I don't know, I feel like that's kind of part of a lot of the mentality, is just like finding things to like, ways to make things easier, which I guess we're like designing our process. It gets like really meta. I don't know, I can't think of anything right now off the top of my head, but I do find it really cool that I feel like a lot of our tools that we've been developing have kind of been like building off of each other. So it's like we started with the web toolkit, and then it was like, wow, like this is really powerful. And then we found like ourselves kind of like wanting more from it, or like realizing the full potential of it. And I think maybe we're even still realizing the full potential of it. And then that kind of, I think, evolved into sandboxes. And I feel like I feel like sandboxes also kind of inspired unit cards on some level too. And like, I think, I don't know, like one thing about unit cards that I find really interesting just from a design perspective is that like we show all of these different states of things, but they're also tied to like use cases. Like I've been talking with some other designers about this, and how like it's not just this like one state in the code, but it also is tied to like the situation that like a user is in. Like a seller can't select a category because like all these other things have happened, and there's like this whole story that like leads them to why they're here. And I think kind of, yeah, I was having a conversation with I think Henry about this like a couple of weeks ago maybe, but I don't know, I think that's really interesting. I guess, I don't know, I'm also gonna say I don't know. I think that's a powerful thing to say, but
to narrow the question maybe,
Yeah.
like I know that we currently use a prototyping tool called I want to say it's called InVision.
yeah.
And like is prototyping an area where you just wish there was better tooling? Is it like we use it because it's the best thing out there so far? And like what does a prototype tool for your design organization look like?
Yeah, I think there are definitely a lot of prototyping tools out there. There's a lot that we kind of have built internally, and a lot of external tools. And I think with prototyping tools, usually there are just different variables to consider. Like, do you want to make something really quickly? And I think that's where like sandboxes kind of came in. Or it's like, do you need to be able to like show different states of something? Or is it just like you're trying to test a flow? Like there are all these different considerations. And so Like, I think usually it seems like anything that can help me get there faster is because, like, you're in the process of trying to solve a problem, and so you need to quickly be able to, like, see a lot of different problems at once and, like, start to narrow from there. So anything that makes it faster, like when we, like, I think at first we didn't have a lot of JavaScript loading up in sandboxes, and so you could, like, show an overlay, but you couldn't have it do anything. And then once we actually got the ability to just, like, with data attributes, like, just really quickly, like, hook up an overlay, I think, like, that changed a lot of things because it made it, like, really faster to be able to, like, show the things that you wanted to do. So, yeah, it's fascinating.
Cool. I
Hopefully
mean,
that helped.
those are all really like cool questions that I just never think of when I'm building
Yeah.
the tool that helps me build something. So
You should talk to all the designers around you.
yeah, I
and
know.
ask them.
Yeah, it's again. I wish I had that infinite time, infinite money that I was
Totally.
talking about earlier. But yeah, for
Cool.
sure.
Thank you.
Yep.
Oh, it's like a spelling bee. For the AV person, Alex. So, your rig is real badass. It's really cool, but it seems to solve the, was it one-to-many problem? I tend to work in politics where we have this. I don't know if you saw it, but it was like a month and a half ago in the Trump train wreck. There was this horrible conference call where the Republicans set this thing up, and like, it was just everyone was on open mic, and that actually happens a lot in DC. And so, like, with your badass video switcher, I was wondering if you guys had tried to deal with a one-to-many problem where, like, you have a primary person speaking, then you want to have a bunch of other folks, like, being able to ask questions and stuff like that.
Yeah, I think that's an issue everywhere, including here. So this room is really great for broadcasting. It's not great for remote activity or discussion. We've had a couple different iterations of rooms that we use for that. In our old building, we had a room with ceiling mics, so that had its own issues of quality. In this building, across the sky bridge, we have what we call our multi-purpose rooms, and basically people have to pass mics around. As far as everyone having their mics on, I think that a lot of our remotes have picked up the practice of muting themselves, and with video, you can mute your camera and your mic upon entering. And as admin, we can place like a hard mute on rooms. So if we know that it's going to be a meeting where only a few people are speaking, we can hard mute the room, have those people join, and then unmute those people. So then we won't have the issue of people randomly unmuting their mics and typing and that kind of thing.
But these pan and tilts, there's still a human being that has to do like control, right?
Yes, yeah.
So one of the cool toys that I built was using like the Pi Vision thing. We had a ball that was chroma keyed, and if you toss the ball around, the camera would just keep following the ball, which led to really, really fun games. Like
That's badass.
Great drinking games. But I was just hoping that you guys had something.
Also on video, not with these specific cameras, but you can control a room's camera as a remote participant. Not with the ball. That's really cool. We should talk about that after.
All right, thanks.
Thank you.
Hi. Whoa. Too close. Hi. This is for Jessica. Surprise, surprise. I used to work at Etsy on the toolkit, so I'm curious how things have evolved. With the I've forgotten what it was called. The thing that you test like states with.
Unit cards.
Unit cards.
Yeah.
Yeah. I'm kind of curious about the workflow in connection with the web toolkit. So it looked like you were kind of just like testing a particular component in that screenshot. Do you have any sort of like automated tests, or how do you use it if you're like changing something in like the sort of foundation of the system, like perhaps typography or spacing or color or something like that?
So I don't think I can fully speak to the test that we have as well as maybe an engineer on the team could. I don't think we do have automated tests. So like for each component, you can write tests for them. And then we've talked about some automated, or some, honestly, I have no idea. I know there are some tests, but I've never like really dug into them very much. I feel like there's kind of like two use cases for the unicards. Like one is as an engineer, changing something and making sure that like you don't affect something else, and that's kind of where you get to see everything output. And then there's like at the top of, I don't know if you noticed, but at the top of every like state there's a name, and then it has like whether tests are passing or not, and that's kind of like the engineering perspective. And then I think from design it's kind of like how does this affect everything?
Yeah, so maybe on the like workflow side of it, are you testing how that affects the whole system, or like how do you coordinate with other people that might be working on that same component and making sure that like things don't break?
Gotcha. So I think our components, I think I see where you're going with. So the components aren't really related to the web toolkit so much. So it's not like the drop-down component or the overlay component, but it's more like in the neighborhood of seller tools. Like this is a part of the listing form, and like all the form fields are each their own thing. And so it's not quite like one-to-one with the web toolkit in a way. It's more like related to like the product, I guess.
Okay, so it's not like globally, it's just like within that context.
No, not yet.
Okay, that's cool.
One day.
Okay, thanks.
Thanks.
Are there any more questions really quickly? Well, I would invite you to talk to the speakers after the fact. We will be hanging out here for a little bit. Thank you, everybody, for coming. It is so wonderful to see faces in the crowd. And most especially, thank you, Steffi, Davina, Ayla, Jessica, Alex, Katrina, Mike, Marielle, Maddie, Sarah, other people who I'm forgetting their names. You all made this happen, and please enjoy some pickles.